Very good evening to all of you. So today we are going to start the new subject, fluid mechanics, and as far as the importance of this subject is concerned, this subject is very important for the interview purpose and for the GATE examination or any other examinations that are relevant to the chemical engineering discipline. तो ये सब्जेक्ट बहुत ही इम्पोर्टेंट है और इंटरव्यू पॉइंट ऑफ व्यू से भी और किसी भी इंटरव्यू में या गेट एग्जामिनेशन के पॉइंट ऑफ व्यू से भी बहुत ज़्यादा ही इम्पोर्टेंट है. हीट आधा छूट गया है तो जब तक एफएम चल रहा है पैरेलली में हीट को कंप्लीट कर लीजिए सर, ठीक है ना. नाउ इट्स माय रिक्वेस्ट टू ऑल ऑफ यू हूएवर हैव नॉट कंप्लीटेड हीट ट्रांसफर पैरेलली along with the fluid mechanics they should complete the at least chapter convection. कन्वेक्शन को कंप्लीट कर लेंगे. कंडक्शन कन्वेक्शन अप टू कन्वेक्शन दे मस्ट कंप्लीट इन नेक्स्ट 10 days. In next 10 days they must complete the fluid mechanics heat transfer. Okay, now so dear student, before starting the subject I would like to discuss about the introduction about the fluid mechanics and what different topics we are going to cover in this course. So as you know, the subject we are going to study is fluid mechanics and first of all I would like to define what is a fluid and then what is the role of fluid mechanics. So how can you define the fluid? And it's very common definition. Fluid is a substance. How can you define the fluid? Anyone? Fluid is a substance which shows continuous deformation. Be careful. Fluid is a substance which shows continuous deformation when subjected under the action of shear stress of any magnitude. Yeah, obviously that is very good. The fluid is substance which has ability to flow. Yeah, or in general you can say the fluid is a substance which shows continuous deformation that continuously deform when it is subjected to the any magnitude, किसी भी even a small magnitude, है ना. So first of all you should write here fluid. Fluid is a substance that continuously deform under action of shear force or stress of any magnitude. Any means not zero, means magnitude may be other small or irrespective of magnitude. Even the small amount of force applied on the fluid will cause its to continuous deformation. That is called as fluid. Is this clear? Follow. The fluid is substance which deforms continuously. Fluid is substance which deforms continuously under the action of shear force, however small it may be. Yeah, irrespective of its magnitude. Even the small shear force can cause a continuous deformation. Clear hai? Bolo. That is fluid here. It means when suppose if you have a very wide parallel plates, you have two parallel plates and let's say bottom is fixed, bottom plate is stationary and top plate is allowed to pull with the force F, and if in between the fluid is confined, if here the fluid is confined in between the two parallel plates, if the fluid is there in between the two parallel plates. Okay, now in this case what happened, if you're going to apply the shear force Fs, shear force, because top plate is moving and the bottom plate is fixed or stationary, it means by applying the shear force which causes the velocity u on the top plate, due to this shear force what happened, the fluid will continuously deform. That is called as fluid. How it is different from the solid, or in general the definition of the fluid is said as you told already, fluid is substance which has ability, which has tendency to flow. Yeah, but in mechanics point of view the fluid is defined as substance that deforms continuously under the action of shear force of any magnitude. Clear? So there must be a continuous deformation. I will discuss later on what is the meaning of continuous deformation and what is meaning of sustained or fixed deformation. What happened? Alright. So in mechanics point of view we can define the fluid is substance that continuously deform under the action of shear force of any magnitude. This is called as fluid. Or in general, if you want to define the fluid is substance which have tendency to flow, okay, which are capable to flow is called as fluid, which have a nature of fluidity is called as fluid. In general, you can define the fluid. It is a definition from mechanics point of view. Otherwise, fluid is defined as a substance that have tendency to flow or having nature of fluidity. Is this clear? कैमरा ब्लिंक कर रहा है क्या यार? मनी मैम, fluidity means ability to flow, tendency to flow. Now it is clear? No. What is fluid mechanics? What is fluid mechanics? अभी सही चल रहा है ना? Fluid mechanics actually, this is a branch of science and engineering that deals with all the fundamental laws that governs the flow of fluid. Means जो भी law like Bernoulli equations, like Pascal's law, hydrostatics law, these all are the laws which governs the flow of fluid. Either the fluid is in the motion or the fluid is stationary. है ना? So all these laws which governs the flow of fluid when the fluid is either at the rest or in the motion, that is going to be studied under the subject of fluid mechanics. Clear hai? The fluid mechanics is the branch of science and engineering that deals with all the physical laws, just governs all the physical laws, all the fundamental laws, all the physical laws that governs the flow of fluid and establish the relationship among various properties of the fluid like density, viscosity, velocity, temperature, etc. to show the behavior of the fluid. So it is a branch of science and engineering that deals with all the fundamental laws that governs, that possess the flow of fluid and also establishes a relationship among various properties of the fluid. For example, density, viscosity, velocity, etc. to show the behavior of fluid either in rest or in motion. क्लियर है? बोलो, एनी प्रॉब्लम? मीन्स डिफिनेशन एक कोई डिफिनेशन नहीं है, सिंपल है कि जो भी ये एक ऐसा सब्जेक्ट है और ऐसा फ्लूइड मैकेनिक्स इज अ ब्रांच ऑफ साइंस एंड इंजीनियरिंग दैट डील्स विद, ये क्या करता है? ये उन लॉज से डील करता है जो फ्लो ऑफ फ्लूइड को गवर्न करते हैं, पॉज करते हैं, जैसे कि बर्नौलीज इक्वेशन, like Pascal's law, hydrostatics law, Navier-Stokes equations, all any fundamental laws that governs the flow of fluid, and also establishes it. This subject also establishes the relationship among the various properties of the fluid to show the behavior. Because if you want to show the behavior of the fluid, if you want to establish the pressure field, velocity field, then you should have a proper relationship among the various properties of the fluid to show the behavior. Means pressure field, velocity field, how the velocity field is there, how the pressure field is there, how the stress field is there. Either the fluid is in the rest or in the motion, in both conditions. Clear hai? In one line, if you want to define the simple, it is a branch of science and engineering that deals with all the fundamental laws that governs the flow of fluid. Either the fluid is at the rest or in the motion. A simple line. Clear hai? In simple one line, you can define the fluid mechanics is the branch of science and engineering that deals with all the fundamental laws that governs the flow of fluid. Either the fluid is in the motion or in the rest condition. Clear? No need to define these all terms. So it is a branch of science and engineering that deals with all the fundamental laws. कोई बोलता है what is fluid mechanics? भाई आप जा रहे हो इंटरव्यू में, कोई पूछता है या सिंपल क्या पढ़ रहे हो भाई, किसी क्लास चल रही है फ्लूइड मैकेनिक्स की, क्या होता है फ्लूइड मैकेनिक्स? The fluid mechanics is the branch of science and engineering that deals with all the fundamental laws that follow the flow of fluid, and either the fluid is in the motion or in the rest condition. दोनों कंडीशन में, फ्लूइड रेस्ट में हो या मोशन में हो. Okay? In both conditions, whatever the fundamental laws are there, that we are going to study under the subject fluid mechanics. Clear? As definition of the fluid, I told you there is two definitions. One is general definition. In general definition, fluid is the substance that have tendency to flow, is called as fluid. But what is definition of the fluid from mechanics point of view? Please write both definition. One definition is already I told you, this definition is basic definition. The fluid is defined as substance that have tendency to flow or having the nature of fluidity, is called as fluid. But from mechanics point of view, we can define the fluid as a substance that continuously deforms under action of shear force of any magnitude, clear, or which have tendency to deform continuously, which deforms continuously under the action of shear force, irrespective of magnitude, irrespective of its magnitude, how small the shear force is. You can also apply shear stress, na? Clear? Shear force acting per unit area, per unit tangential area is called as shear stress. Clear? Please write definition. Through definition, one is general, other is mechanics point of view. How the fluid is different from the solids, that I am going to do you. Difference between fluid and solid. And you know, whenever I am going to tell you fluid means either liquid and gas. Liquid and gas, both comes under the category of fluid. Clear? Now, first of all, the difference in the fluid and solid we can define by the quantum theory of the gases, as we know very well, because fluid have tendency to deform. It means in the fluid every molecules are moving randomly with various velocity in various directions. No need to write, because fluid either liquid or gas, the intermolecular force of attraction among the molecules are negligible in the case of gases and very small in the case of liquids, and their positions are not fixed at their lattice as in the case of solid. Am I right? As same thing I told you in the fluid, in the heat transfer as well. So you no need to write, because most of the points you should only understand, you should not write. Now the first difference in the fluid and the solid is that unlike in the case of fluid, unlike in the case of solid, unlike as in the solids, the position of the molecules are not fixed at their lattice. Their positions are random. The molecules can move randomly in various directions with various velocities, and that's why they are fluid, because they have tendency to flow. While in the case of solids, the position of the molecules are fixed at their lattice, and lattice is periodic arrangement of the molecules, is called as lattice. Okay, it is the first basic difference. And as far as intermolecular force is concerned, the intermolecular force of attraction in the liquid is small and it is negligible in the case of gases. In the gases, the intermolecular force of attraction is zero or negligible, you can say, in the case of gases, but it will present in the liquids, but of a small magnitude. So intermolecular force is small in the liquids and it is negligible, is absent in the case of gases, while it is very strong in the case of solids, and that's why their positions are fixed at their lattice in the solids. Mr. Aniket Kapote, what happened, sir? ठीक है, Mr. Aniket. Okay, listen here. Mr. Aniket, now it is clear. Come to the point here. Difference between the fluid and solids. So from mechanics point of view, what is the difference here? That is a simple common difference, as I told you. When you have two very large parallel plates, and if the fluid is going to fill, suppose here the fluid is there, plates, and here fluid is there, and one similar plate is here, and there is solid. This is solid. So in between the same two parallel plates, where the bottom plate is fixed and the top plate is moving, the bottom plate is fixed and top plate is moving. Clear? With the velocity force Fs, and here again with shear force Fs, the plate is moving with the velocity V. So here the two parallel plates are there. Just try to understand. The two parallel plates is there, and that in between the parallel plates the fluid is filled here, and here the solid is there. For example, let's say any elastic solid, just like a steel, we placed, and they are mechanically attached with the top, and if the top plate is subjected to the shear force Fs, which causes the velocity V on the top plate, and the bottom plate is stationary, then what we'll observe, अरे भैया तन्मय यार, सर फिक्स तो होता है ना पोजीशन सर, तन्मय सर, आप आंसर खुद पा जाओगे सर। पोजीशन तो फिक्स होता है ना सर, मैं फिक्स की बात कर रहा हूँ यहाँ पे, ठीक है ना सर। we here fluid, okay, bottom plate is fixed and top plate is moving. When this is the case, then in this case here deformation is continuous. It means at time t equal to t naught, it means initially, that is the fluid is at their position, okay, like A and B. At time t1, this is the deformation, it become B prime. At time t2, B double prime, and so on, and that is called as, come karo, the deformation is continuous. Clear hai? Here deformation is continuous, but here in the solids, if I apply the same shear force, then deformation is fixed. Means time is not playing important role. There is no continuous deformation there, fixed deformation is there. Here in the fluid, in the fluid, there is first key point is continuous deformation. Continuous means with the time t1, t2, t3, t4, deformation is continuous. But here the fixed deformation is there. It means in the both cases on the top plate we are going to apply the force. But in the case of fluid, whatever the force has been applied, that force is resisted by the fluid under the continuous deformation. Under the, obviously whatever force we apply, that force would be absorbed, that stress is going to be absorbed by the fluid in continuous deformation, continuous equilibrium is there. But in the case of solids, whatever the force we applied, that force is going to be resist, that force is going to be resisted by the solid under fixed equilibrium condition, and here dynamic equilibrium condition is there. So here equilibrium is dynamic and here equilibrium is fixed. Are you getting the point? Yes or no? The basic difference. Bolo, clear hai? In solid, there is definite deformation is there, or fixed deformation is there under the action of shear force. Means whatever the force we have applied over the solid, the applied shear force, applied shear stress will resist by the solid under the state of static equilibrium condition. And in the case of fluid, whatever the shear force we applied, that shear force is going to be resist by the fluid under the dynamic equilibrium condition. Dynamic means because equilibrium is going to be changed with time. That's why called dynamic equilibrium condition, and that's why there is a continuous deformation. Clear hai? And due to dynamic equilibrium condition, the fluid have tendency to flow. As I told you, why the fluid have tendency to flow? Because when the force is applied, when any small, even small magnitude, any magnitude of the force is going to be applied over the fluid, then the fluid will resist that shear force under the dynamic equilibrium condition. Is this clear? And here continuous deformation is there. The first difference is continuous deformation when the shear force is applied, and in the case of solid there is a definite deformation. Now second difference, in the fluid, whatever the shear force has been applied, that force is going to be resisted by the fluid under the dynamic equilibrium condition, and that dynamic equilibrium condition is the reason, is responsible for the fluid to flow. Now second is, in the case of solids, whatever the shear force has been applied, that shear force is also going to be resisted by the solid, but in under the definite, under the static equilibrium condition. The two, static and dynamic. Static equilibrium condition will attain in the case of solids. Now, and here the fixed deformation is there. Okay, deformation is not going to change with the time. Is this clear? Now the second basic difference is that, third basic difference, if we are going to remove the applied shear stress, on removal of the applied shear stress, the solid partially or fully regain their original size depending upon how much elasticity is there. Is this clear? If the deformation is under the elastic limit, then the solid object can regain its original shape. So either fully or partially, the solid will regain their its original shape either partially or fully. Clear? On the removal of the load or stress. But in the fluid, on the removal of the load, the fluid never regain their its original shape. And only the exception is viscoelastic fluid, that I will discuss later on. But in general, common fluid will never attain their initial shape. Even on the removal of the stress, अगर आप stress remove करोगे, the fluid will never regain their its original shape. It means the fluid is substance. In engineering field, we are saying कि fluid is substance having zero memory, and why the solid is substance having perfect memory. Why? Because on the removal of the load, the solid object will regain their its original shape, because the solid object know what was its original shape. That's why it will try to come into its initial state, while the fluid will never come its initial state. Is this clear? In the case of solids, we are going to use the Hooke's law to define the applied stress, because whatever stress we have applied, that stress causes the deformation, and stress proportional to deformation, and that deformation is d theta. D theta, and here also the d theta is there, but this d theta is going to vary with the time. The angular deformation is d theta. Is this clear? There is an angular deformation, and that angular deformation is called d theta. Here A and B, and here A, B prime only. No further deformation is there. So there is fixed deformation here d theta. So in the case of solids, the stress under the action of shear stress, under the action of shear force, stress is proportional to. In the case of solids, stress is proportional to deformation, and deformation is called as strain. Is this clear? So here stress is proportional to strain, or stress proportional to deformation. But in the case of fluid, stress is whatever stress we applied, whatever force we applied, that force will cause a continuous deformation. Then along with the deformation d theta, there is one more term is there called as time. Stress proportional to d theta as well as time. That's why we can't say stress proportional to strain or deformation. Then what we should say? Stress proportional to rate of deformation. Rate of deformation. Is this clear? Why? Because time is there. Or you can say stress proportional to rate of strain. There is basic difference in the fluid and solids. Now it is clear? बोलो clear है? So please write some points about that. If you want to write, you can draw this figure. तन्मय सर एक बार समझने की कोशिश करिए, मैं बताऊंगा बार बार, बट ट्राई करो कि एक बार में ही समझ में आ जाए. सर स्ट्रेन समझते हो ना, हुक्स लॉ समझते हो? हुक्स लॉ में क्या होता है कि स्ट्रेस प्रोपोर्शनल स्ट्रेन. स्ट्रेन क्या होता है कि डिफरेंट डिफॉर्मेशन, कितना डिफॉर्मेशन हुआ, स्ट्रेन, एंगुलर डिफॉर्मेशन. तन्मय सर फ्लूइड में क्या हो रहा है? फ्लूइड में स्ट्रेन के साथ साथ ये स्ट्रेन डिफॉर्मेशन यहाँ भी है और यहाँ भी है. दोनों में अंतर क्या है? यहाँ पे डिफॉर्मेशन टाइम से चेंज हो रहा है, T0, T1, T2, T3, T4, because and that is the property, because whatever the stress you have applied over the fluid, that stress, that force will resist by the fluid under dynamic equilibrium condition, and that is the only responsible for the fluid to flow. Why? What is the responsible for any fluid to flow under the action of shear force? That is dynamic equilibrium, because you can say कि fluid resists any deformation, fluid resists any stress applied under the dynamic equilibrium condition, and since there is dynamic equilibrium is there, it means the deformation is going to change continuously with time. Deformation is changing continuously with the time, and that will cause for the fluid to flow. That is responsible for the fluid to flow. Is this clear, तन्मय सर? जो भी स्ट्रेस अप्लाई कर रहे हो, सेम स्ट्रेस आपने अप्लाई किया फ्लूइड में भी और सॉलिड में भी. सॉलिड में जो स्ट्रेस अप्लाई किया, सॉलिड ने उस स्ट्रेस को रजिस्ट किया. अगर मैं आपको धक्का देता हूं तो आप रजिस्ट करोगे ना. तो अगर मैं स्ट्रेस अप्लाई किया, फोर्स अप्लाई किया, देन दैट फोर्स, दैट स्ट्रेस इज गोइंग टू बी रजिस्ट बाय द सॉलिड under the static equilibrium condition. Why static? Because deformation is definite, fixed deformation is there. While in the case of fluid, if the same stress is going to apply, that causes the continuous deformation because of dynamic equilibrium condition is there. Because whatever the stress you have applied, that stress is going to be resisted by the fluid under the dynamic equilibrium condition. And since the stress is going to be resisted by the fluid under dynamic equilibrium condition, that is the reason for the fluid to flow. That causes the fluid to flow. Clear? Fluid. First point, it shows continuous deformation under action of applied stress or force. Okay, second point, applied stress or force, whatever you can say, applied stress or force, stress लिखो आप, अदरवाइज आप समझ लोगे. applied stress will resist by fluid under dynamic equilibrium condition which causes the fluid to flow because of continuous deformation. Okay, मैम शियर फोर्स का मतलब जो भी फोर्स टेंजेंशियल लगता है, अभी बताऊंगा सर मैम. मतलब खींच रहे हो, एक दो प्लेट है, इसको इसके ऊपर खींच रहे हो. मैंने ऑलरेडी ये सब चीज़ें हीट में बता चुका हूँ, बट फिर बताऊंगा, डोंट वरी, पहले लिख लीजिए. अप्लाइड स्ट्रेस विल रेजिस्ट बाय द फ्लूइड अंडर डायनामिक इक्विलिब्रियम कंडीशन विच कॉजेज द फ्लूइड टू फ्लो. थर्ड पॉइंट क्लियर है. फर्स्ट पॉइंट, इट शोज कंटिन्यूअस डिफॉर्मेशन अंडर एक्शन ऑफ अप्लाइड स्ट्रेस. अप्लाइड स्ट्रेस विल रेजिस्ट बाय द फ्लूइड अंडर, जो भी स्ट्रेस आपने अप्लाई किया है वो फ्लूइड रेजिस्ट करेगा किस कंडीशन में, अंडर डायनामिक इक्विलिब्रियम कंडीशन, एंड विच कॉजेज फॉर द फ्लूइड टू फ्लो. ओके, ऑन रिमूवल of applied stress or fluid never regain its original shape. It means fluid is called a substance having no memory. It is about the fluid. Clear? Have you written this? Fluid is called a substance having no memory or zero memory. Karthik, clear? Now solid. It shows fixed deformation or definite deformation under applied stress. Second, applied stress will resist by solid under static equilibrium condition. What do you mean by static? Third, on removal of load, solid may either fully or partially regain its original shape. It means solid is substance having perfect memory. Clear? And fourth, stress versus strain. Stress is proportional to strain here. Proportional to strain by Hooke's law. Stress is proportional to strain in solids. And here, please write this. In the case of fourth point, we can write in the fluid, stress proportional to rate of strain. Now clear? Any problem? No, here you can write, please, fourth point, stress proportional to rate of strain, not strain. Rate of strain, stress proportional to rate of strain, and that is given by Newton's law of viscosity. Newton's law of viscosity. सौम्या सिंह. Difference क्या है? Why rate is there? Because time is important factor. Along with deformation, time is also there. भाई परफेक्ट मेमोरी परफॉर्म कैसे आ जाएगा यार? मैं बोल भी तो रहा हूँ यार, परफेक्ट मेमोरी परफॉर्म मेमोरी क्या होता है? चलो मुझे सही से लिखना पड़ेगा अब. So here Hooke's law and there Newton's law of viscosity. But Newton's law of viscosity, it means, listen here, that difference I told you. So in fluid, stress is proportional to rate of strain or rate of deformation. Okay. So before starting the other discussion, I would like to discuss the shear force, as Ms. Soumya Singh has asked. What is shear force? Shear force is the force which causes, the force that causes a relative displacement. One layer over other layer, another adjacent layer is called shear force. मतलब समझे नहीं समझे? एक ये है, एक ये है. ये लेयर का रिलेटिव डिस्प्लेसमेंट. इट मीन सपोज ये मूव कर रहा है 2 मीटर पर सेकंड से, दो लेयर है, दो solid optical, let's say we have a 2 solid plates, one plate here, other plate here. It is moving, one plate, 2 plate. I have a 2 plate. First plate is moving with 2 meter per second and second is moving with 3 meter per second. It means there is a displacement. There is a relative displacement of the second layer over the first layer by 1 meter per second. Are you getting it? But if bath is moving with 2 meter per second, there is no shear force. Shear force, it means there must be a relative displacement. The force that causes the relative displacement of one layer over the another is called as shear, and the force which causes this type of flow is called as shear force. Clear है? बोलो सौम्या, नहीं समझ में आ रहा है? Shear का मतलब क्या है? First सुनो shear. Shear means relative displacement. Shear means relative displacement. Displacement of one layer over other is called as shear. And what is shear force? The force which causes this type of displacement is called as shear force. For example, if one plate is there and other plate is there, and this plate is, let's say, stationary, and this plate is moving, and let's say they are in the direct contact. They are in the, it is first plate, it is second plate, first plate, second plate, and now the second plate we are going to pull with the force F. Then this force will cause a relative displacement of the second layer of the solids particles, solid plates, over the first layer. So that force is called as shear force. Now clear, Soumya? And what is shear stress? The shear force acting per unit tangential area is called as shear stress. What is shear stress? Shear force acting per unit tangential area called shear stress. Now it is clear? Bolo. First is shear. Shear is the relative displacement of one layer over other layer. Is called a shear, and the force which causes that displacement is called a shear force, and the shear force acting per unit tangential area is called a shear stress. Not normal area, it must be tangential area. Tangential area. Okay? बताओ भाई clear है या नहीं? तो difference in the fluids and solid is clear. Shear force, shear and shear stress is clear. Now, and as I told you, कि stress proportional to in the fluid, stress proportional to rate of strain, na? But this is only correct for which fluid? Newtonian fluid. Newtonian fluids like oil, water, air, etc. For all common fluids. So stress is directly proportional to rate of strain, that is given by Newton's law of viscosity and called as Newtonian fluids. The fluid which obeys the Newton's law of viscosity is called as Newtonian fluids. And the example of Newtonian fluid is oil, water, all engineering fluid is called as Newtonian, like oil, water, air, etc. Okay, but there are some fluids like toothpaste, some other fluids like toothpaste, mayonnaise, and और क्या था? Toothpaste हो गया, mayonnaise हो गया, और example slurries, jam, ketchup. These types of fluid cannot be easily classified. etc. cannot be easily classified. Can't be easily classified. Why? Because their behavior, they behave as solids when the applied stress is below the yield stress. When the applied stress is below the yield stress, they are going to act as solids. And when the applied stress is beyond the yield stress, they will behave as a fluid. Are you getting it? So whatever I told you, stress is proportional to directly proportional to rate of strain. That is only for the common fluids like oil, water, air, etc. Called as Newtonian fluids, which obeys the Newton's law. This is called Newton's law of viscosity. It means from Newton's law of viscosity, stress is proportional to. It is also called as Newton's law of viscosity. Newton's law of viscosity. From Newton's law of viscosity, stress is proportional to strain or rate of strain. Anyone? Stress is proportional to strain or rate of strain. By Hooke's law, you can say stress is proportional to strain. Hooke's law is valid for solids, and Newton's law of viscosity for the fluids. Which fluids? Newtonian fluids, like oil, water, air, etc. Some other fluids like toothpaste, mayonnaise, slurries, jam, ketchup, etc. They can't be easily classified as a Newtonian fluids. And in this case, the stress is not directly proportional to strain, because these types of fluids will behave as solids when the applied stress is below the yield stress. What is yield stress? Because you know very well, if you want to squeeze the toothpaste from the tube, then obviously you have to apply some stress. And if the applied stress is below some definite stress, the toothpaste is not able to come out. But once you have applied the stress beyond some yield stress, some definite stress, then what happens? The toothpaste will act as a fluid. It will start to flow. Am I right? Yes or no? Same thing is going to mayonnaise. If you are going to place the mayonnaise here, it will act. Suppose if you want to place the mayonnaise over the burger, then if you place here, then obviously it will like a solids. But if you're going to apply a brush to make a lap, once the stress we are going to apply by the brush is exceeding beyond the yield value, then it can easily flow, and that will act as a fluid. So before yield stress it will act as solids, and beyond the yield stress it will act as fluid. Now it is clear below. And that types of fluid is called Bingham plastic fluid. Yes, मसूद जी कनेक्शन सही कर लीजिए. सुनिए, स्ट्रेस प्रोपोर्शनल टू रेट ऑफ स्ट्रेन, दैट इज न्यूटन्स लॉ ऑफ विस्कोसिटी. और यही मैंने बोला था फ्लूइड में, है ना. बट ये जो बिहेवियर है, स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू रेट ऑफ स्ट्रेन, दैट इज ओनली शोन बाय द न्यूटोनियन फ्लूइड्स like oil, water, air, etc. So how can you classify, how can you define the Newtonian fluid? The fluid which obeys the Newton's law of viscosity. It means the fluid in which the stress is directly proportional to strain, that is called as Newtonian fluid. Some other fluids like toothpaste, mayonnaise, slurries, jam, ketchup. toothpaste हो गया, mayonnaise हो गया, slurries हो गया, jam हो गया, ketchup हो गया, ये सारे जो fluids हैं, in that types of fluid stress is not directly proportional to strain. Means these fluids doesn't obey the Newton's law of viscosity. In why? Because these fluids are acting as solids before yield stress. When the applied stress over these fluids are lower than the yield stress, then they will act as solids. And when the applied stress is beyond the yield stress, they will act as a fluids. Clear है? Toothpaste है, toothpaste को for example suppose आपने toothpaste यहाँ पे निकाल दिया. A P of toothpaste is there. This is P of toothpaste. Now if you are going to apply the stress, if you are going to blow air, what happen? They will, that P of P means क्या? P means और toothpaste का एक part. अब toothpaste आपने निकाल लिया है ब्रश पे, suppose ब्रश पे लगा लिया आपने, ये ब्रश टूथ ब्रश है, यहाँ पे लगा लिया आपने, and if you blow the air with your mouth, then that toothpaste will not deform. Why? Because whatever stress you are going to apply by blowing the air will not able to reach its yield stress. But once you are going to blow with very high velocity, and once that velocity will cause the stress more than the yield stress, that will get deformed. Clear? Same thing is going to happen with the mayonnaise. If you want to apply the mayonnaise over the bread with a spoon or with knife, then you should apply the stress with the knife more than the yield stress if you want to flow it over the bread. Same thing is going to happen with slurries. A ketchup. Have you seen the ketchup? If you want to apply the ketchup over the bread, what happen? You should apply the stress of force with the spoon or with the knife more than the yield stress. And what yield stress is? Yield stress is going to be defined differently with the different fluids. क्या ट्राई करोगे भाई? ये तो देखा ही होगा ना भाई यार. ठीक है मसूद खान जी. तो some other fluids like toothpaste, mayonnaise, slurries, jam, ketchup, etc. can't be easily classified since, in the same line, since they will behave as solid if applied stress is below yield stress, but if applied shear stress exceed the yield stress, the substance will act as a fluid, will behave as fluid. Clear है? बताओ. Some other material like paint, like quicksand. What is quicksand? Water sand mixture is called quicksand. Water corn starch. देखा है water corn starch? आपने देखा होगा वो कॉर्न को उसमें मिलाते हैं ना. अगर ग्रेवी गाढ़ी बनानी है तो दे आर गोइंग टू यूज स्पेशली इन द वो क्या बोलते हैं उसको यार, मंचूरियन है. तो कॉर्न और वाटर को मिक्स करते हैं, एंड इफ दे आर गोइंग टू स्टीर फॉर सफिशिएंट टाइम, है ना, देन देयर इट विल बिकम मोर थिकन्स. यस नो? देखा है कभी? राइट डाउन प्लीज. सम अदर मटेरियल लाइक पेंट, क्विकसैंड, इवन जिप्सम. आपने देखा होगा वाटर इन जिप्सम. अगर जिप्सम में वाटर मिक्स कर दो तो इट्स बिहेवियर इज गोइंग टू चेंज द टाइम, है ना. तो दैट इज ऑल्सो कॉल्ड एज दैट टाइप्स ऑफ फ्लूइड ऑल्सो डोंट फॉलो द न्यूटन्स लॉ ऑफ विस्कोसिटी. तो मटेरियल लाइक पेंट, क्विकसैंड, वाटर कॉर्न, स्टार्च, etc. डोंट फॉलो न्यूटन्स लॉ ऑफ विस्कोसिटी. Newton's law of viscosity मतलब क्या है कि stress is not directly proportional to strain. That is only meaning. And the study of that types of fluid which don't follow the Newton's law of viscosity is called rheology. Yes, shear thickening, shear thinning. तो दिस टाइप्स ऑफ फ्लूइड डोंट फॉलो द न्यूटन्स लॉ ऑफ विस्कोसिटी. न्यूटन्स लॉ ऑफ विस्कोसिटी का मतलब क्या है कि जहाँ पे स्ट्रेस प्रोपोर्शनल टू स्ट्रेन नहीं है, अरे सॉरी, रेट ऑफ डिफॉर्मेशन नहीं है डायरेक्टली, यानी स्टडी ऑफ दैट टाइप्स ऑफ फ्लूइड will come under the rheology. Yes, rheology of the fluids. Rheology means study of non-Newtonian fluids. The fluid which don't follow the Newton's law of viscosity is called as rheology. The study of fluids which don't follow the Newton's law of viscosity is called as rheology. मसूद खान, जो फ्लूइड न्यूटन्स लॉ ऑफ विस्कोसिटी को फॉलो नहीं करते हैं उसे बोलते हैं नॉन न्यूटोनियन फ्लूइड्स, और नॉन न्यूटोनियन फ्लूइड्स के बिहेवियर की स्टडी हम करते हैं रियोलॉजी के अंडर. समझ गया? बोलो सौम्या सिंह. क्लियर? तो stress is proportional to, directly proportional to rate of strain only for the common fluids like Newtonian fluids, oil, water, air, etc. Although I will further classify this in later on. So that is the basic difference in the solids and fluid. Now it is clear? Bolo. Now next is continuum hypothesis. C-O-N-T, continuum hypothesis. What is continuum hypothesis? Anyone have idea about this? Continuum hypothesis. What is the meaning of continuous hypothesis? Very important. अभी तक मैंने कुछ भी नया नहीं बताया, केवल मैंने डिफरेंस बताया सॉलिड्स में, फ्लूइड्स में, वो दिमाग में बैठ गया होगा. अब मैं बात करता हूँ कंटिन्यूम हाइपोथेसिस. व्हाट इज ए कंटिन्यूम हाइपोथेसिस? कंटिन्यूम, मिस्टर कार्थिक, एनी प्रॉब्लम अप टू दिस पॉइंट? नाउ माय क्वेश्चन इज, व्हाट डू यू नो अबाउट कंटिन्यूम हाइपोथेसिस? या, फ्लूइड इज सेड टू बी अ कंटिन्यूम इफ देयर इज नो होल्स इन इट. होल्स मीन्स गैप. वेरी गुड. ईश्वर केदार, excellent. Continuous medium, excellent. No words, no gaps. Yes. Fluid is assumed to be a, it means if you want to define the properties, because to show the behavior of the fluid you must define the properties. Na? Without properties you can't show the behavior of the fluids. You can't describe the behavior. So in order to describe the behavior of the fluid you must define the properties. Property means like density, velocity, temperature, etc. Viscosities. The various properties are there that must be defined in order to describe the behavior of the fluid. समझ गए? किसी भी फ्लूइड के बिहेवियर को डिफाइन करने के लिए आपको प्रॉपर्टी को डिफाइन करना पड़ेगा, है ना? एंड प्रॉपर्टी मीन्स, प्रॉपर्टी क्या क्या है? डेंसिटी है, विस्कोसिटी है, टेम्परेचर है, प्रेशर है, एटसेट्रा. इट इज क्लियर? नाउ बट in this hypothesis we are going to assume कि properties of the fluid is a continuous, property of the fluid is assumed to be a continuous function of space and time. Continuous function of space and time, or in other words, at a given time all the properties of the fluid is a function of space only, because time is fixed there. So at any instant the properties is a continuous function of space. It means at any given instant of time, at all points the molecule must be there. Now, and why this hypothesis is required? Reason is that, listen carefully. Suppose, no need to write, try to understand, sir, try to understand. Yes, very good. Suppose this is a room, no? This is a room. Let's say 1 meter, it's a volume of 1 meter cube. 1 into 1 into 1 of 1 meter cube. Dimension of the room is 1 meter cube. In 1 meter cube, obviously, at a temperature and normal temperature and normal pressure, at standard temperature and pressure, you know very well, how much number of molecules are there? At standard temperature and pressure, as you know, 22.4 liter volume will occupy, you know very well. If I am going to assume idle guess, 22.4 liter volume will contain 6.023 into 10 power 23 molecules. Am I right? At STP. Am I right? Yes or no? Bolo. Very good. Means 22.4 liter volume will contain that much molecules at standard temperature and pressure. Then and 1 meter cube, it means around, in 1 meter cube you can see, in 1 meter cube volume will occupy around 6.023 into 10 power 23 upon, please tell me approx value is what at STP? Approx value is what? Anyone? What is approx value? In 1 meter cube volume of the container, how much number of molecules must be there? Because 22.4 liter, in 1 liter there is a 10 power minus 3 cube meter cube. Approx 3 into 10 power 25 approx molecules that are there in 1 meter cube volume, and there are very huge number of molecules. Actually there are very huge number of molecules. Can you imagine in that much, in 1 meter length, height and width, LBH, approx 3 into 10 power 25 molecules are present, and that are very large number of molecules. It means even the fluids, listen here. And as far definition of the fluid is concerned, the fluid, especially in the gases, the intermolecular force of attraction is negligible. It means the mean free path. Try to mean free path. Molecules are very apart from each other and they are moving randomly here and there. Suppose this is any here, molecules are moving randomly and there is a mean free path, lambda is very high at normal pressure, because intermolecular force of attraction is negligible. That's why the mean free path. What is mean free path? It is the average distance traveled by the molecules for the two successive collision is called as mean free path. The average distance traveled by the molecules for the two successive collision is called as mean free path. As pressure increases, what happens? If the pressure is very high, all the atmospheric pressure is very low pressure. When the pressure is very high, what happens? The molecules are come close to each other and mean free path is going to be decreases. And the number of collision will get increases. Are you getting it? So in general, I am talking about standard temperature and pressure. So in general, what happens? The gases are assumed to be moving randomly in various direction, and there is some space is there. There must be some space of magnitude millimeter. Space is there, and that space is gap is called mean free path. Am I right? It means suppose there is a molecules are there. Try to understand, sir. If this I am going to define as a system, a volume in which we want to define the property of the whole room of 1 meter cube. I am choosing this space, this volume as a region in which we want to define the property, any property like density, viscosity, temperature, pressure, etc. भाई जाधव साहब कंफ्यूज हो गए हैं आप बहुत बड़े. सर वॉल्यूम को मोल से कैसे तुम कंपेयर कर रहे हो यार? वह क्लियर करो इसके डाउट भाई. सर एसटीपी पे 1 मोल गैस जो है वो 22.4 लीटर वॉल्यूम ही ऑक्यूपाई करता है. ये पता होना चाहिए आप. अरे यार जाधव साहब क्या कर रहे हैं आप? इतना बड़ा कन्फ्यूजन कहाँ लिए क्रिएट करते हैं? अवगातुल्ला ये है कि 1 मोल ऑफ एनी गैस at standard temperature and pressure will occupy the volume of 22.4 liter and will contains the 6.023 into 10 power 23 molecules. समझ गए जादू सर? अब मेरे कहने का मतलब क्या है? अगर suppose if I have chosen the very small, Mr. Karthik, if in 1 meter cube of the space volume, if I am going to choose only 1 decimeter cube volume, 1 decimeter cube is 1000 times less than the 1 meter cube, yes or no? Because in 1 decimeter cube I am going to consider a small 1 decimeter cube. This volume we are going to consider, and in this region only we are going to define the property like density, viscosity, temperature, pressure, etc. So this volume is 1000 times less than the volume of the 1 meter cube, yes or no? Bolo. Or you can say the 1 meter cube volume is 1000 times more. Am I right? Yeah. Now then what is the logic? What I am going to tell you, if you, in this case it seems that this gap is there, no? Because at any given instant, for example, because molecules are moving randomly, so at some instant there may be some molecules. If I am going to enlarge here, let's say if I am going to enlarge, so this section I am going to enlarge here, तो it may be possible, ये हो सकता है ना कि भाई molecules तो move कर रहे हैं, तो किसी instant पे यहाँ पे molecules present हो, किसी molecules पे present नहीं हो. Incoming and outgoing is continuous there because molecules are random. So at some instant of the time, it may be possible that some molecules may present in that volume of 1 decimeter cube. Another instant it may not be there. Yes or no? It may be also possible. It means at a given instant there may be a possibility that no molecules are there. If no molecules are going to be observed at any instant, then we can't define the property. Because to define the property, obviously we are going to define the property of the molecules. Because two approaches there. One is called microscopic and macroscopic. In microscopic approach, we should define the property of individual molecule. And it is very difficult to observe the behavior or to define the property of individual molecules. That's why we are always going to bother about the macroscopic properties. Macroscopic property means we, without bothering about any event occurring at the molecular level, without bothering about any event, बिना ये समझे कि molecular level पे क्या हो रहा है, molecules कैसे move कर रहे हैं, कैसे घूम रहे हैं, इन सबके टेंशन लिए बिना, without bothering about any event occurring at the molecular level, we can define the property, we can measure the property by the instrument. An instrument like we can measure the temperature by thermometer, we can measure the pressure by the pressure gauge, we can measure the viscosity by viscometer. Okay, so we can measure the property macroscopically without bothering any event which are going to occurring at the molecular level. Means we should not bother about key, because actually the pressure, listen here, try to understand, sir, try to understand what is pressure. How can define the pressure? Anyone? whatever definition you told me, na, pressure is force upon area, that is actually, sir, that is actually macroscopic definition. That is actually macroscopic definition, and that you are going to measure directly pressure by the, no, let's say force upon area. So have you calculated the force? Suppose this is a tank, and in this the gas is filled here. Now, as you know, the pressure is force upon area. Have you ever calculated how much force is going to be applied by the molecules on the wall of the container? Have you ever applied? No. You simply place the pressure gauge and you directly measure the pressure. Now, because as per definition, listen, sir, pressure is defined as rate of change of momentum is force, yes or no? Time rate of change of momentum, it means rate of change of momentum with respect to time is called as time rate of change of momentum is force, and force acting per unit area is called as pressure. So time rate of change of momentum per unit area is called as pressure. And what momentum I am bothering about? What momentum? Actually, listen, suppose, sir, listen, if this is the, I am just going to clear each and everything. Suppose if you have a container and there is vacuum is there, outside the container there is vacuum is there, है ना, and in the container, ध्यान सुनना, ये कंटेनर है और कंटेनर के बाहर वैक्यूम है. वैक्यूम का मतलब कोई भी मॉलिक्यूल्स नहीं है यहाँ पे, कंप्लीट एब्सेंटी इज देयर. नो, एंड हियर सम गैसियस मॉलिक्यूल्स आर देयर and some gaseous molecules are there. Let's say the mass, total mass of the gaseous molecule is m and velocity is v here. Velocity is v. Now, as the molecules are going to be collide on the wall, what happen? As they are going to collide, they return back, and actually they are going to exchange their momentum. And to transfer the momentum, as they are going to strike, they are going to apply the force. And as they are going to strike on the wall, they are going to change its velocity and direction. Yes or no? Velocity as the molecules are going to strike on the wall, as the molecules are going to strike on the wall, on striking on the wall, that molecules will change its direction as well as its magnitude. Yes or no? जैसे ही ये molecules इस wall पे strike करेंगे तो they will obviously change its direction as well as its magnitude. Velocity का जो magnitude होगा वो भी change होगा and direction will also change. Yes or no? And as they will change its, means there is a change in momentum. Yes or no? Means as they are going to strike on the wall, before striking and after striking, there is change in momentum. There is a change in momentum. And from Newton's third law of motion, whatever the equal and opposite force will be applied, then rate of change of momentum acting per unit area is called as rate of change of time rate of change of momentum per unit area is called as pressure. Is this clear? Now, and if, because vacuum is there, no molecules are there, but if there is no vacuum, if no vacuum is there, some atmospheric pressure is there. Atmosphere, we are going to place this container in atmosphere. Then what happen? There is a continuous bombardment is there, because outside there is also molecules are there. Air molecules are at atmospheric pressure. Now their continuous bombardment is there on this wall, and there is a net rate of change of momentum, because some bombardment is from the outside and some is from the inside. In that case, we should bother about the net rate. We कौन सा effect ज़्यादा होगा? Then pressure is going, net pressure is going to apply either inside or outside, will depend upon which is stronger. So net rate of change of momentum is called as pressure. Clear है? तो actually the pressure is time rate of change of momentum per unit area is called as pressure. But we never, have you ever calculated the rate of change of momentum of the molecules? No, ना, कभी आपने calculate नहीं किया. Why? Because actually it is a microscopic approach. It is a microscopic approach. And here vacuum means no bombardment from the right side. But if we are going to place the container in the atmospheric pressure, then the continuous bombardment from the outside and inside. In that case, the net rate of change of momentum acting per unit area is called as pressure. So that is called as microscopic approach. But in macroscopic approach, we are not going to calculate these things. And why we are not going to calculate, I will discuss it. I will discuss it. Why we are not going to bother about this. So macroscopic approach is the average of result of microscopic approach. Yeah. So in engineering applications, there is no need of calculation of the properties at the molecular level. We can directly calculate the properties at the microscopic level by using the devices like pressure gauge, temperature thermometers, etc. Now, so listen here, come to this point. Actually, I told you, Mr. Karthik, listen, and Mr. XYZ, everyone, कि if I have considered the very small region in the space, like 1 decimeter cube, in 1 decimeter cube, this volume, let's say it is 1000 times, but it has been observed from experiment कि at standard temperature and pressure there is 1000th number of molecules are there. There is 1000 means there is a 3 into 10 की power 22 molecules are there. Are you getting it? It means if you want to define density in the very density, mass per unit volume, yes or no, or molecules per unit volume, then if you see here 3 into 10 to the power 22 upon 1 decimeter cube, per decimeter cube, it is found to be same as a whole. As a whole, it is found to be what? 3 into 10 to the power 25 upon 1 meter cube. And if you change 1 meter cube in decimeter cube, you will find the same value. So density we can define either at small level or large level. It is found to be same. Why? Because it has been found from the experiment कि if we are going to reduce the volume to 1000 times, then number of molecules is also approximately not exactly by 1000, but approximately 1000 times. Then density will remain same. Are you getting this? And that is only possible when we are going to assume there is no holes are there, no gaps are there. Means at any instant किसी भी given time पे ऐसा नहीं होगा कि molecules present ना हो. और कितने होंगे present? They are nearly same. समझ गया? तो molecules भी उसी rate से भी decrease हुए, approximately same rate. Exactly same rate नहीं बोल सकते हो, but approximately same rate. Are you getting it? अगर 1 meter cube, if in 1 meter cube volume that much molecules are there, in 1 decimeter cube volume, then which is 1000 times less than the volume of 1 meter cube, then number of molecules is also reduced by 1000 times. Then density will remain same here. Are you getting it? And that we can, it is only hypothesis. That is only hypothesis, and that I will discuss in which condition it is exactly valid, in which it is not exactly valid. Now, so it means, sir, if we are going to consider, this is the x, y, z, if we are going to consider a small region in a space, and in this we are going to assume a small differential element. If we are going to exaggerate this, इस पूरे में small हमने एक volume element assume किया है, और इस volume element में किसी given point C पे, at any given point C, if you want to define the density, if you want to define the density at any given point C in this region, in a large cube we have considered small volume of differential element that is called as dV, and in this small differential volume dV, at any given point I am going to define the property like density, viscosity, temperature, pressure. Any property we can define by assuming कि at any given instant we can define the property, because property is a continuous function of space. It means at all space, at all points there is a molecules. So only the thing is that there should be no any holes. At any instant, at all positions, there must be molecules, so that we can define the property. अगर किसी स्टैंड पे मॉलिक्यूल्स प्रेजेंट नहीं है तो वहाँ पे प्रॉपर्टी डिफाइन नहीं कर पाएंगे, बट ऐसा नहीं होता है. इन दिस हाइपोथेसिस वी आर गोइंग टू अज्यूम इन ऑल अपकमिंग फ्लूइड मैकेनिक्स स्टडी, वी आर ऑलवेज गोइंग टू अज्यूम कि कंटिन्यूम इज ऑलवेज वैलिड. कंटिन्यूम मीन्स ऑलवेज द मॉलिक्यूल्स आर प्रेजेंट एट एनी स्टैंड, देयर इज नो गैप्स, नो होल्स. Means property is assumed to be a continuous function of space and time. Property is a continuous function of space and time. Is this clear? It means at each and every point the property is differentiable. df upon dx. At any given point the property, if f is any function, this is differentiable function. Is this clear? Yes or no? Property is differentiable. It means it is a continuous function of space and time. समझ में आ गया नहीं आ गया बताओ. So whatever the fluid mechanics we are going to start now onward, that in that we are going to assume कि property is all at any given instant, at all space, property is defined. Means molecules are present, no holes, no gaps are there. As you know, we can define the density as limit delta V tends to 0. It is differential volume delta V. I told you delta V. This is found to be dm upon dV. Is this clear? This is the definition of density we can define. Here listen carefully. Rho and this is called delta V. Please listen here. If we are going to choose delta V as a very small, what happen? If we are going to assume delta V, this differential volume, Mr. Karthik, if this is the differential volume delta V, and if we are going to assume very small volume, what happen? Very small. If very small volume we are going to assume, what happen? there may be possibility there is a fluctuations are there. Why fluctuations are there? There is large fluctuation is there. Why is the large fluctuation? Because it may be possible that there is no molecules is there, because volume is very small, and if this volume is very small as compared to mean free path, भाई mean at least इतने गैप होने चाहिए ना. ये जो मॉलिक्यूल्स के बीच में जो लेमडा है, यहाँ तो गैप तो रहेगा ही रहेगा. और अगर आपने जो कैरेक्टरिस्टिक लेंथ लिया है of the volume, suppose you have assumed the differential volume that is less than whatever the differential element you have considered, and that is lie between the mean free path, then obviously there is gap is there. ये जो element है बहुत gap में है, and gap is there, it means at any instant it may be possible कि some molecules are there, then it will indicate zero value, then there is large fluctuations are there, and these fluctuations are going to be stabilized as we are going to increase the volume. Are you getting it? Yes or no? बोलो. And they are going to be stabilized here and then like that. Please first draw this, then I will discuss it. Why the large fluctuation? This is the density, because I told you, and this is delta V prime. I will discuss why delta V prime. Yes, if the differential element we are going to consider is very small, if differential element that we are going to consider is very small as compared to mean free path, जो गैप है मॉलिक्यूल्स के बीच में उससे भी कम है, तो वहाँ पे तो मॉलिक्यूल्स में भी पॉसिबल कि देयर इज नो मॉलिक्यूल्स आर देयर एट सम इंस्टेंट. तो एट एनी इंस्टेंट इफ इट इज फाउंड कि नो मॉलिक्यूल्स आर देयर, देन देयर इज अ लार्ज फ्लक्चुएशंस आर देयर. Large fluctuations we are going to observe here. Clear? So as delta V increases, then less fluctuations are there. Why? Because as delta V increases, then the fluctuations of uncertainty in the probability of the molecules to present is going to be increases. Now, and here this delta V prime is sufficient enough. Here delta V, we are going to produce constant value of density. When the delta V is more than delta V prime, what happens? We are going to obtain constant value of the density. It means in that region, when we are going to choose the control volume in such that which volume is more than delta V prime. Yes, you can write. You should write this. Whatever figure I am going to write, you should write. Otherwise, समझ गए हो तो समझना important है. पहले समझ लो. अगर डेल्टा वी की वैल्यू डेल्टा वी प्राइम से ज़्यादा है तो यहाँ पे क्या हो गया, नाउ दैट डेल्टा वी जो हमने जूम किया कंट्रोल वॉल्यूम, ये सफिशिएंट एनफ है कि एवरी टाइम्स मॉलिक्यूल्स आर प्रेजेंट एंड वी कैन डिफाइन द प्रॉपर्टीज ए कंटिन्यूअस फंक्शन. ये सुनो, बोलो. मीन्स कंटिन्यूम इज वेल इन दिस रीजन. व्हाट हैपन बियॉन्ड दिस रीजन? एनीवन? व्हाट हैपन इन द बियॉन्ड दिस रीजन? इफ वी आर गोइंग टू कंसिडर द वॉल्यूम which is very large, when we are going to assume, for example, try to understand it, and suppose this is the 1 meter cube volume. If you are going to increase the volume, very large volume we are going to consider here. In this case, what we are going to lag behind? Yes, Umar, I will discuss it. Not only more than, but also it should be less than. Means whatever the volume we are going to assume, that control volume should be large enough. That control volume should be large enough that control volume should be large enough. It means delta V should be more than delta V prime, large enough to confirm कि properties is a continuous function of space. Means at any given instant, at all points, the molecules must be present. And it should be small enough. It should be large enough and it should be small enough. Small enough in what sense? It should be small enough so that if you're going to listen here, if you're going to consider the delta V is a very large volume, 90% of the volume you are going to assume as a control volume, then what happens? You are going to we are not going to account the effect of spatial variation, है ना. स्पेशियल वेरिएशन को हम अकाउंट नहीं कर पाएंगे ना. CU. Fluctuation indicates you probability of molecules are less, molecules probability of the molecules to be present are less in that differential element. Present होना चाहिए उस differential element में probability बहुत कम है. It means at some extent it may be there, some extent may not be there. It's common sense to say कि अगर आप बहुत ही small लेते हो तो वहाँ पे probability है ना कि वहाँ molecules नहीं होंगे किसी टाइम पे हो भी सकते हैं. बट अगर large बहुत ज़्यादा ले लोगे, अगर आपने वॉल्यूम बहुत ज़्यादा ही ले लिया, फिर क्या होगा? In that case you are not able to observe the property variation due to spatial effect. स्पेस के साथ वेरिएशन नहीं देख पाओगे फिर. You are not able to observe the spatial variation in the properties. Yes or no? So why these are going to be increases? That is actually, this reason is called as continuum hypothesis. This delta V should not be more than this. If you are going to increase more than this, then you are, if the volume chosen is very large as compared to a very large, in that case you are not able to observe the spatial variation. मैं वही बता रहा हूं सर, ये ग्राफ इंक्रीज कर रहा है. क्यों इंक्रीज कर रहा है? पर सुनोगे, सुन तो रहे नहीं हो, वही मैं बता रहा हूं. क्यों इंक्रीज कर रहा है बताओ, किसने, कौन समझा? वाई इट इज इंक्रीजिंग? दैट एब्रप्ट बिहेवियर इज इंडिकेटिंग यू. ये जो बिहेवियर है दैट इंडिकेट्स यू, बिकॉज इफ यू आर गोइंग टू चूज द कंट्रोल वॉल्यूम इज वेरी लार्ज, तो एनी वेरिएशन ड्यू टू स्पेस यू आर नॉट एबल टू ऑब्जर्व ना. फॉर एग्जाम्पल, रूम के इस साइड में एसी लगा हुआ है. फॉर एग्जाम्पल यहाँ पे एसी लगाया हो, ये एसी है. फॉर एग्जाम्पल at this corner the AC is there. If you are going to assume a small control volume, there is obviously you are going to at this point the temperature is different. Here temperature is, let's say, 25 and here temperature is 35. Am I right? Yes or no? There is a variation in temperature with the space is there. Yes or no? But if you are going to assume the whole as a control volume, then you are not able to observe this variation of 25 and 35. Yes or no? Are you getting a point? Suppose if this is a room and in this corner AC is there, then obviously nearby AC the temperature is 25 in this control volume. In this control volume temperature is 35. It means there is a spatial variation is there in the properties. Temperature is going to vary with the space. Yes or no? Means we are able to observe the spatial variation. If the control volume is small, then we are able to observe the spatial variation. But if we are going to assume the whole as a control volume, then we are not able to observe the spatial variation. So that volume that we are going to consider, that should be small enough to account any spatial variation, and it should be large enough to ensure that molecules are always present. Are you getting it? Small enough and large enough. Large enough in the sense of कि every times the molecules must be present, we can define the property. And small enough, it should not be too large so that we can't account the spatial variation. It should not be too small so that we can't define the property कि no molecules are there. Now, is this clear, Mr. Kedar? Mr. Mehta, why these variations are there? The two limitation is there. This is called as microscopic limitation. This is microscopic limitation. Microscopic limitation. And that is again one limitation called macroscopic limitation. Macroscopic limitation. तो जो कंट्रोल वॉल्यूम में जूम करोगे वो ज़्यादा बड़ा भी नहीं हो, किससे? इट शुड नॉट बी लार्ज इनफ so that we can't account the spatial variation. It should not be small enough so that no molecules are present at all time. It means limitation or uncertainty. Macroscopic limitation or uncertainty. Uncertainty is there. And in that region only the continuum is valid. Continuum hypothesis in that region. Clear hai? It means whatever volume we are going to assume, that should be small enough and large enough to that. So this region, in this region, the continuum is not valid. And in the fluid mechanics, whatever the study we are going to start, that is only in this region. Means region in which we are going to assume the continuum is valid. Is this clear? And that delta V should be order of 10⁻⁸ meter cube. And in all engineering applications, all the volume is obviously more than 10⁻⁸ meter cube. That's why we are going to assume that continuum is always valid in engineering applications. This volume is much less than that. Volume is much less. That volume is much less. So in that region, what happened when the molecules, when we are choosing the control volume less than this delta V prime, when we are going to choose the volume, differential volume less than delta V prime, what happened? Then at an instant molecules are there and not another instant not there. If the molecules at any instant is there, then we can define the property, and if not there, then we can't define the property. That's why the fluctuations are there. Depending upon how many number of molecules are there, density is going to vary. But as we are going to increase differential volume, then the fluctuations are going to be decreases, and that is going to be cancels out when delta V is of order 10⁻⁸ meter cube. Bolo, is this clear? Yes or no? How many of you are able to got the information about this? किसको तो समझ में आ गया? हाँ, दोनों हो सकता है. ये अनसर्टेनिटी दिखा रहा है, तो कुछ भी बना लो. तो दिस इज द कॉन्सेप्ट ऑफ कंटिन्यूम. हमने जो लिखा बिल्कुल भी नहीं है, लेकिन समझ उतना लिया है जितना अभी तक समझे नहीं थे. ये बात सही है गलत है? So it should not be too large so that we can't account the spatial variation. It should not be too small so that no number of molecules are present at any instant. That's simple. So all further study we are going to start by assuming the continuum is valid. Okay. Now in the liquids always the continuum is valid. Why? Because in the liquids molecules are close enough as compared to gases. Yes or no? In liquid, the continuum is always valid. You should not bother. You should close your eyes and always assume the continuum is valid whenever we are talking about liquids. Why? Reason is that because in the liquids, the mean free path is very small as compared to gases. Because in the gases, molecules are too apart. Molecules are very apart to each other because intermolecular force is negligible or very less as compared to liquids. In the liquids, although intermolecular force is not zero, but they are less. And that's why the molecules are close enough to each other. And since the molecules are close enough to each other, then always the continuum is valid no matter how much small differential element we are going to assume. Clear hai? In the fluid, always the continuum is valid, but always the problem is we are always in dilemma for the case of gases. In the gases, maybe there, may not be there. It depends upon the characteristic length of the object that we are going to choose. And by I've told you one common sense, characteristic length will define the size of the element that we are going to choose, size of the differential element that we are going to choose. Yes or no? बोलो. मानते हो या नहीं मानते हो? Liquids में molecules are very close to each other. That's why at no matter how much small differential volume we are going to choose, always the continuum is valid. But the problem is always with the gases. Why in the gases? Because when we are dealing with the gases with the low pressure, for the gases with high pressure, continuum is always valid. Yes or no? But gases with low pressure, continuum may be valid, may not be valid. But which will decide how much less and how much large pressure so be required to have a continuum to be valid? Problem है कि नहीं? मैंने बोला in the gases, when the pressure is very high, at high pressure, large pressure, the mean free path is small, molecules are close enough to each other, then the continuum can be assumed to be valid. But when we are dealing with the low pressure applications, then the mean free path is more, then there may be chance of holes. But the question is how much small and how much less, how much small and how much large pressure is sufficient to ensure the continuum is valid. That is going to be decided by a number called Knudsen number. Clear है? थोड़ा वो फ्लूइड हमको आता है कि नहीं आता है? बताओ कौन सा नंबर? Knudsen नंबर. एक बार बोल के मैं छोड़ नहीं दूंगा, तुरंत बोल दिए कौन सा नंबर. ये सब खुद से लिखो नोट्स. Knudsen number, and these numbers are important. Kn, Knudsen number. So Knudsen number is important for the gases at low pressure or rarefied gases. Rarefied means very low pressure gases. So in high pressure gases again the continuum is valid. You should not bother about कि valid है कि नहीं है, टेंशन ले रहे हो नहीं. टेंशन कब लेना है? टेंशन you should take only when we are dealing with the low pressure gases. And obviously in this case the lambda will play an important role, because as low pressure is there, lambda is very large, and lambda is what? The average distance traveled by the molecule for the two successive collision is called lambda. Yes or no? Bolo. So in this case, if LC is called a characteristic dimension. If the characteristic dimension, sorry, inverse is the lambda by LC. Mid there, lambda by LC. Yes. If the characteristic dimension of the problem lies between the lambda, if LC is more than lambda, then what happen? Anyone? Just use common sense and tell me answer. If LC is more than lambda, if the characteristic dimension of the object of the problem, if the characteristic dimension of the problem is more than the mean free path, in that case, the continuum is valid or not? Yeah, then it is valid. Yes, very good. Then here the first point is that if Knudsen number is found to be less than 0.01, and less than means when the LC is very more than lambda, in that case then continuum is valid. continuum is valid when the Knudsen number is more than 0.01 but less than 0.1. That is called slip flow. And here continuum concept is not valid. Third, when Knudsen number is found to be more than 1.0, 0.1 से 1.0 था, I'm sorry, when more than 1.0, then it is called as free molecular flow. Free molecular flow. Clear है? And again in these two regions the continuum is not valid. It is only valid in this region. बोलो clear है? एक ट्रांजिशन भी होता है एक मिनट सॉरी, हाँ स्लिप फ्लो, अरे यार हालांकि तुमको इतना जानने की जरूरत नहीं है बट फिर भी मैं बता देता हूँ. दूसरा जो हो गया नड्सन नंबर मोर देन 0.01 लेस देन 0.1, दैट इज स्लिप फ्लो. तीसरा, when Knudsen number is more than 0.1 less than 1.0, transition flow, transition. And when Knudsen number is more than 1.0, fourth, it is called as free molecular flow. Free molecular flow. Please write. Because for the continuum to valid, obviously your characteristic length should not be less than. If it is less than, then obviously the molecules there may be because lambda ही ज़्यादा है तो gap तो always there ना. At an instant may be possible कि no molecules are there. But if you are going to choose the control volume or characteristic dimension more than this mean free path, then there is chance, there is always some molecules may be present, and that is because continuum is valid in this region. So it is for the gases. So this is for the gases. Continuum is valid when the Knudsen number is less than 0.01. It is clear? Bolo. So for liquids always the continuum is valid. For the gases at the low pressure, for the gases at low pressure there is a dilemma. But gases at high pressure continuum is again valid. So whenever we are dealing with the gases at low pressure, then there is a problem. And then at the gases at low pressure, when the Knudsen number is less than 0.01, then it is valid, otherwise not. Clear है? बोलो clear. Can you write from your own? Yes or no? नहीं, इस सर प्रेशर की वैल्यू से हम लैम्डा डिफाइन करेंगे. सर लैम्डा इज द मीन फ्री पाथ. केदार सर, lambda is the mean free path and LC is the characteristic dimension of the system. For example, if you are dealing with the pipe flow, in the pipe flow LC is what? Anyone? Diameter. And if gases are going to flow, it's use common sense to say if the LC is, let's say, 2 millimeter, and that is your diameter of the pipe is 2 millimeter, and the mean free path is itself, means the distance between the gaseous molecule for the collision is found to be 3 millimeter. Then what happens in this case? Anyone? So free molecular flow means when the Knudsen number is more than 1.0. It means, have you heard about diffusion in the mass transfer? When Knudsen number, यहाँ से देखो ना मेहता साहब, when Knudsen number is more than 1.0 means lambda is more than, here lambda is more than LC. If lambda is more than LC, then what happens? Free molecular flow means when Knudsen number is more than 1.0, and it is only when the lambda is more than LC, means mean free path is more than LC is the characteristic dimension, that is your LC. Suppose the gas is going to flow inside. In that condition, whatever diffusion is there, that is by the Knudsen diffusion. Yes, Soumya, excellent. Characteristic length is the length of the system. It is a characteristic dimension of the system. It is going to vary. For example, if we are dealing with the flow in the pipe, then LC is the diameter. Now it is clear, Mr. Kedar? So that is going to play important role only for the case of low pressure. In the high pressure, always the continuum is valid in the case of gases. So in the liquids, always continuum is valid. In the gases at high pressure continuum is valid, but in the case of gas or low pressure, we can decide by the Nodson number. Clear? So whatever the discussion we are going to write continue now onward, that we always assume the continuum is valid. That's it. So you can write some points about that, about the continuum hypothesis. Property of the fluid is always assumed to be a continuous function, continuous function of space and time. It means at any instant property is a function of space. Also, there is no holes or gap in control volume. That is enough. Property is a function of space. Means property is differentiable. Differentiable का मतलब क्या होता है? डिफरेंशिएबल का मतलब at any point property is differentiable. df upon dx is the space exist. It is differentiable at any given point. This is called as f at x plus dx minus f at x upon delta x when delta x limit delta x tends to 0. So at each and every point we can define the property, means it is differentiable at each every point. Property is differentiable, and the main points I told you already. You should write in short form. This all points you should write in short form, like this figure you should write. Bolo, clear? You should draw this figure so that you can understand what I told you. तो यहाँ पे मैंने क्या बोला था कि ये 1 मीटर क्यूब वॉल्यूम हमने लिया था, 1 मीटर क्यूब डायमेंशन. इतने डायमेंशन में इतने मॉलिक्यूल्स प्रेजेंट हैं एसटीपी पे, और अगर हमने एक स्मॉल कंट्रोल वॉल्यूम एज्यूम किया है जिसका वॉल्यूम 1 डेसीमीटर क्यूब है, 1 डेसीमीटर क्यूब which is 1000 times less, then it is found that the molecules is also approximately 1000, not exactly 1000 times less, but approximately 1000. So the density will remain same. Density won't change. And now अब सुन लो बहुत ही इंपॉर्टेंट पॉइंट्स. हम now I told you the difference of pressure. Pressure is the time rate of change of momentum per unit area is called as pressure. Time rate of change of momentum per unit area is called as pressure, na? But we never calculate the rate of change of momentum. We always going to use the pressure gauges. So whatever gauge we are going to use, that gauge have a size. The whatever gauge we are going to use, that size is large enough to the mean free path. Are you getting the point? Their LC, sorry, the LC is small enough to mean free path. It means mean free path is large enough as compared to the LC of the object that we are going to insert it. Is this clear? It means that whatever device we are going to insert is a thermometer. Whatever thermometer we are going to insert here to measure temperature, that capacity dimension or that control volume of this element, this control volume or whatever the element we are going to insert to measure the temperature or pressure, that capacity dimension is lie in the Knudsen number less than LC larger than ना, हाँ सही है. Yeah, yes, LC should be larger than lambda. Yes, very. I'm sorry. तुम लोग ज़्यादा होशियार हो. LC should be larger than whatever the no, Mr. Iswar Kedar. What is LC? LC is the dimension over which we are going to see the flow. So if you are going to insert any device, that device have a characteristic dimension that is more than the lambda, and that's why the Knudsen number is found to be very very more than lambda. That's why the Knudsen number is found to be less than 0.01, and that's why always the continuum is going to be valid, and we are able to calculate the exact pressure or exact temperature, and by macroscopic analysis. Clear? Yeah. तो जो भी डिवाइस हम इंसर्ट कर रहे हैं मेजर करने के लिए, उसका जो कैटेगरी डायमेंशन है, that is enough, more enough as compared to lambda, and it will lie in the range of Knudsen number 0.01, so that the continuum is valid. And if it is liquids, then no need to worry. If the case of gases and high pressure, no need to worry. We are always going to be in dilemma in the case of gases at the low pressure. Now, why temperature? How can define temperature at the molecular level? Temperature is defined as the time rate of change of average kinetic energy of the molecules, because as they are going to collide, the kinetic energy of the molecules are going to be changed, and kinetic energy is measure of temperature. The time rate of change of kinetic energy of the molecule is called as temperature. So we never calculate the kinetic energy. We simply insert a probe called as thermometer, and we are able to measure temperature, because whatever the probe we are going to insert, that LC is more than lambda. Slip flow means when the Knudsen number lie between these two, that is slip flow. बताया तो या no slip flow क्या है? Slip flow and all these types of flow only we have in हमारे सिलेबस में केवल ये है. हमको केवल इस रीजन की बात करनी है, मैंने लिखवा दिया हूँ. Only we should bother about this flow in the case of gases at low pressure. The gases in the low pressure in these types of region like slip flow, transition flow, free molecular flow, it is beyond our syllabus. It is beyond our study. So today I told you कि whatever the discussion we are going to start, only that discussion will continue for the where continuum is valid. We should not bother about all other types of flow region like slip flow and transition flow and free molecular flow. That is beyond our syllabus. Okay, next heading is fluid. This is the first chapter, that is introduction. So I completed introduction about the fluid. What is fluid? Why difference in the fluids and solid, and how can define the fluids from the common definition and from the mechanics point of view. Okay. I told you the fluid. How can I define the fluids? Two ways is there. One is the fluid which has ability to flow is called fluid. From the mechanics point of view, fluid is a substance which deforms continuously under the action of shear force, even with the small magnitude of the shear force. Okay. Now, what is difference in the fluids and solids? When the shear force is going to apply over the solids, the solid resists the shear force under the condition of static equilibrium. When the shear force is going to apply over the fluids, then the fluid will resist the shear force under the action of dynamic equilibrium condition, and that causes the fluid to flow, and that will indicate the continuous deformation. And upon removal of the load, fluid will never regain their original shape, except for the one exception is there for the fluid called viscoelastic fluid. Have you heard about viscoelastic fluid? One fluid is there called viscoelastic fluid, which will regain its original shape when the stress is removed. That is special. Only one exception is there called viscoelastic fluid. Except for the viscoelastic fluid, you should write at that point, at that topic. Upon removal of the load, the fluid will never regain its original shape except for the viscoelastic fluid. Now, any example of viscoelastic fluid? Anyone? Viscoelastic. The viscoelastic is the which have property of viscosity as well as elasticity. दोनों की property है उसके पास. Viscoelastic fluid. No, not honey. No. Float draft. Yeah, Disha. You are somewhat correct. Rubber is not fluid, Subham. Rubber is solid. Rubber solid है. Yeah, polymer is somewhat correct, but all polymer. Have you heard about vinyl fluid? Not grease. Yeah, float draft is somewhat correct. Polymer is somewhat correct, but which polymer? Have you heard about vinyl fluid? Please search. Please go for Google search. Vinyl fluid, the fluid which found in your knees. स्प्रिंग यार, स्प्रिंग तो सॉलिड हो गया ना, मैं फ्लूइड की बात कर रहा हूँ मैम. फिर तो बहुत सारे हैं ना. शुगर सिरप यार. प्लीज गो फॉर गूगल सर्च वाइनियल फ्लूइड, द फ्लूइड विच आर प्रेजेंट इन नीज, जो घुटनों में रहता है. गो फॉर गूगल सर्च. स्नोवियल फ्लूइड. Maybe I pronounce it wrongly, but is synovial or vanual? Synovial, okay. So when you are walking or running, what happens? When the jerk is going to be found, the fluid will compress, but when the jerk is not there, then again it will regain its original shape. That is called viscoelastic fluid. Are you getting it? Now please write next is fluid properties. Second chapter. First chapter was introduction. Now second chapter is fluid property. हाँ, जब वो दौड़ोगे तो दो बोन के बीच में कंप्रेस होगा, उसका शेप चेंज होगा, फ्लूइड फ्लो होगा, बट जैसे ही आप रेस्ट करोगे तो अगेन इट्स रीगेन इट्स ओरिजिनल शेप. पहली बार सुने हो कि नहीं सुने, बताओ. फ्लूइड प्रॉपर्टी. अब यार ये मुझे भी नहीं पता क्यों ख़त्म होता है भैया. ये तो अब जेनेटिक होता है, तो बायोलॉजी पढ़ना पड़ेगा हमको, तो बताएंगे. ये डॉक्टर भी तुमको नहीं बताएगा, वो बोलेगा भाई जेनेटिक है, तो कोई इसका रीज़न नहीं है. बायोलॉजी पढ़ना ज़्यादा आसान है. बोल दो इसका रीज़न नहीं है, जेनेटिक है. एक ही आंसर दे दो, जेनेटिक है. ओके, राइट. फर्स्ट इज डेंसिटी. फर्स्ट प्रॉपर्टी इज डेंसिटी. How can you find density? Density is defined as the ratio of mass per unit volume. It means in a unit volume, how much mass is there? That is called as density. Mass of the fluid in unit volume. Means unit volume में कितना mass content है, that is called density. Mass per unit volume. Is this clear? And notation is rho here. It is mass m by v. It is unit is kg per meter cube in SI और mk system. Otherwise you know very well कि क्या unit होगी, इसमें बताने की जरूरत नहीं है ना. Density. And you should understand very carefully कि for liquids the variation in density with temperature and pressure is very negligible or very small. There is very small variation in density with temperature and pressure. So for liquids, that's why the liquid is called incompressible. Clear hai? That's why for the liquid is called as incompressible fluids, because the variation in density is very small with temperature and pressure. It means if you want to show for a very large change in temperature, very small change in density is there. Variation is there, but that density change is negligible with temperature. Okay, a small variation. But for the gases, there is large deviation is there. But deviation in what sense? As temperature increases, density will get decreases. density of liquid decreases. You know very well कि as temperature increases, fluid become lighter. Yes or no? In the heat transfer, in the convection, natural convection, you have seen. That is for liquids. As temperature increases, density of the liquid will get decrease, and the pressure effect is nearly negligible. For gases, if you are going to assume ideal gas, then PV equal to nRT, N upon V equal to molar density is equal to P by RT, mass density is equal to PM by RT. Am I right? Yes or no? PM by RT, and this indicates you that it is directly proportional to pressure and inversely proportional to temperature. So for gases, density is inversely proportional to temperature and directly proportional to pressure for gases, and they are highly compressible. Means variation in density with pressure and temperature is sufficiently large in case of gases, and that was very small in the case of liquids. Now it is clear. This is called density, and density is a measure of mass of the fluid in unit volume. कि unit volume में कितना mass है, that is called as density. Okay, and in thermodynamics, inverse of density is called a specific volume. Inverse of density 1 by rho is called a specific volume, meter cube per kg. And that specific volume terms is frequently used in thermodynamics, called a specific volume. A specific volume. Also called mass density and molar density. Two densities there, mass and molar. तो मास में मास आएगा, मोलर में मोल आएगा. समझ गए ना? ये तो ऑलरेडी मैं आई हैड टोल्ड यू इन द प्रोसेस कैलकुलेशन. First property is density. Next is called as specific weight or weight density. Next property is called as specific weight or weight density. This is called as weight of the fluid in unit volume. Means in unit volume how much weight is there. वो mass था, ये weight है. It means it is mg upon v. It is called a rho into g. Yes or no? So specific weight is called rho g. And notation is gamma, rho times g. Now what is difference in the specific weight and mass density? Anyone? Weight density and mass density में क्या difference है बच्चे? बोलो. Density will remain same throughout the location, but specific weight will change with the location because value of g will change. Yes or no? तो g की वैल्यू मून पे अलग है, यहाँ अलग है, तो specific weight different होगा, है कि नहीं? Same substance का. Now listen here, and third is called as relative density or relative density or specific gravity. Specific gravity SG. It is a ratio of density of the fluid to the density of standard fluid. Density of the fluid to the density of standard fluid. For liquid, the standard fluid should be taken as the liquid water. Standard fluid means we are going to measure density with respect to standard fluid. और rho g कर लोगे तो also it is defined as weight density to the weight density of standard fluid, है कि नहीं? और specific gravity is also weight density gamma of the fluid to the gamma of standard fluid. Fluid to the standard fluid. G से मल्टीप्लाई कर लो, ऊपर नीचे डिवाइड, है ना? And now what is the advantage of this? Also it is a measure of density, and also there are densities. The only difference is they are dimensionless. It doesn't depend upon the dimension. In any dimension, in any system, we can use the specific gravity. Are you getting it? That is the beauty of this. But in that it is measure of what? Mass in unit volume. But that specific gravity I can use in any system, either FPS or SI on MKS. In any system I can use the specific gravity because they are dimensionless. It will remain same. If the specific gravity is 13.6 for mercury, it is 13.6. The 13.6 is in all system, either in MKS or in SI or in FPS. सब में सेम ही रहेगा 13.6. तो standard fluid is water at 4 degrees Celsius. For liquid, the standard fluid is water at 4 degrees Celsius, and that is at 4 degrees Celsius, the density of the water is 1000 kg per meter cube. Clear है? बोलो. And for gases, the standard fluid is air itself. Is air. At which temperature, pressure? Anyone? So if you want to calculate the specific gravity of the gases, then you should use the standard fluid as a air and having density 1 kg per meter cube. 1.001 around, approximately it should be 1.0 kg per meter cube. Approximately 1.0 kg per meter cube. Yes, at STP. Very good. So if the fluid is gas, and if you want to calculate the relative density or specific gravity, then we should always use the 1 as a standard fluid density. But if you are using the liquid, then you should use the 1000 kg per meter cube as a water density at 4 degrees Celsius, because density of water at 4 degrees Celsius is maximum. Up to 4 degrees Celsius, the density of water increases. It is accepted, and after that, it starts decreasing as usual. So that, for example, for mercury, for Hg, what is the specific gravity? It should be 13.6 into 10 power 3, that is kg per meter cube. It is the density of the mercury, and this is 10 power 3, it is cancelled out. Then specific gravity of the mercury is 13.6, and that is in all units, all systems. There is no restrictions. Are you getting it? So whatever the properties we discussed so far, that is a measure of heaviness of the fluid. Am I right? The first two property that we discussed, that is the mass density and weight density. They are measure of heaviness of the fluid. Yes or no? They are measure of heaviness. कौन सा heavy है? ये यूनिट वॉल्यूम में कितना मास, ज़्यादा मास होगा ज़्यादा हैवी होगा, है कि नहीं? So whatever the property we discussed so far, that is a measure of heaviness of the fluid. Whatever property we discussed so far, that is a measure of heaviness of the fluid. But those properties, whatever we discussed so far, they are not able to describe the behavior of the fluid. No, they have only measured the heaviness, but they are not able to describe the behavior of the fluid. How the fluid, how the fluid will behave. Under the action of applied forces, how the fluid will flow. Means behavior means what? Flow behavior means whatever the property we discussed so far, like density and a specific density is weight density, they are measure of heaviness. They are not able to define the flow behavior of the fluid. For example, oil and water have nearly same density. Yes or no? Water have density of 1000 kg per meter cube and oil has around 998. If I am correct, yes or no? So water and oil are nearly same density. It means they are equally heavy. But both the fluid will show different behavior when they are applied, when under the action of shear stress, when they are allowed to flow. They flow differently. Their behavior is different when they are applied under action of shear stress. It means when in between two plates, if you are going to place the oil and here water we are going to place, and if you are going to place same shear force of Fs, then the behavior of this fluid and this fluid is different. So which property? Because whatever the property we discussed so far, they are not able to define the flow behavior of the fluids. Oil and water have nearly same density. They are equally heavy. Their density is same, but their flow behavior is different. So which property will show their flow behavior? That is called viscosity. That is called as viscosity. It is clear? The viscosity is the property of the fluid which show the behavior of the fluid under the action of shear force. Okay, how the fluid behave when it is subjected under the action of shear force. When the fluid is subjected under the action of shear force, how the fluid will behave. Although oil and water have same density, but still the behavior is different. So that behavior we are going to measure by the property called as viscosity. Clear? What behavior we are going to observe? If the same shear force we are going to apply, then water will deform more. The rate of deformation in the water is found to be more as compared to deformation in the oil, although they are equally heavy. Under the same shear force, if you are going to apply the shear force Fs and Fs in the oil and water, then water will deform more. Rate of deformation is more faster in the water as compared to oil. Are you getting it? It means the flow behavior is different. Water will deform, a rate of deformation, a rate of strain is larger. The rate of deformation is larger for the same shear force in the water as compared to oil, although they are equally heavy. Clear? The density will not able to define the property of the fluid, but viscosity is the property which will define the behavior of the fluid. Density is only measure of heaviness. Clear? Although I will discuss the viscosity by tomorrow, before this I would like to discuss the one more property, that is called as compressibility. Are you ready? Yes or no? तो डिफरेंस क्लियर हुआ विस्कोसिटी में और डेंसिटी में. तो बिफोर डिस्कसिंग अबाउट द विस्कोसिटी आई वुड लाइक टू डिस्कस द कंप्रेसिबिलिटी. Now, what is compressibility? It is quite interesting to observe the change in volume or density of the fluid of a given mass when subjected to the pressure change. Means when you have, for example, when you have fluid of certain mass, its mass is fixed. A fluid of certain mass, when it is subjected to the pressure, compress, let's say here P here, and when it is going to compress, then the pressure is found to be P plus dV. This additional force we have applied here, P plus dP. So when the fluid will get compressed, then the volume, because mass is fixed here, तो mass equal to volume in density. हमें yes or no? भाई किसी fluid को either liquid है या gas है, कोई भी है, अगर compress करोगे by increasing the pressure, you are compressing the gas by applying the additional pressure. Extra pressure is dP. That causes the differential volume to be decreased from V to V minus dV. Here the P is P plus dP, and here at one point it is better to write. It is 1, it is 2 point, initial and final. At one point the pressure is P, volume is V. At 2 point pressure is P plus dP and the volume is V minus dV. Are you getting it? So when the pressure is applied, the volume will get decreases, yes or no? And the pressure will increase. Any problem? And it is a very important property because everyone is interested in knowing how the fluid is behave, how the fluid volume or density is going to be changed when it is subjected to applied change in pressure. So mass is volume density and mass is fixed here. Then dm equal to 0. This is called as rho into dv. A fractional change in density and fractional change in volume. So you have seen here, if the volume fractional change in volume will get decreases, then density will get increases, and vice versa. If the volume will get decrease, then density will get increase. Yes or no? Minus dv upon dv, minus dv upon v indicate you what? Fractional decrease. Fractional decrease in volume. Then d rho upon rho indicates you fractional increase in density. Fractional increase in density. जब वॉल्यूम डेंसिटी बढ़ेगा तो वॉल्यूम घटेगा. दैट्स इनवर्स रिलेशन बिकॉज मास इज फिक्स हियर. Minus dv upon v indicates you the fractional decrease in the volume, and d rho upon rho indicates you fractional increase in density. Yes or no? बोलो. And the compressibility is a measure of change in volume or density of fluid when it is subjected to the applied pressure change. Are you getting it? Now definition clear है? कोई दिक्कत? Yes, volumetric strain you can say also. तो हाउ कैन डिफाइन द कंप्रेसिबिलिटी. हम क्या मेजर कर रहे हैं? वी आर मेजरिंग एक्चुअली चेंज इन वॉल्यूम और डेंसिटी. यस नो? चेंज इन वॉल्यूम और डेंसिटी विद अप्लाइड चेंज इन प्रेशर. That is a measure by compressibility. So compressibility is a measure of, please write, it is a measure of change in volume, change in volume or density with applied change in pressure. Simple. Compressibility is a measure of change in volume or density with applied change in pressure. Is called as compressibility. And in the fluid mechanics, we are using the term called as bulk modulus of elasticity. Bulk modulus of elasticity. कितने लोगों ने नाम सुना है? बल्क मॉडुलस ऑफ इलास्टिसिटी. प्लीज टेल मी. What notation we are going to use for the bulk modulus of elasticity? Anyone? कौन सा नोटेशन हम यूज करते हैं फॉर द बल्क मॉडुलस ऑफ इलास्टिसिटी? अब याद इसमें क्या करना है, अभी तो ये नहीं भूलेगा ना सर तन्मय जी कि कंप्रेसिबिलिटी क्या होता है. कंप्रेसिबिलिटी मतलब क्या है कि किसी गैस को कंप्रेस करो तो उसका वॉल्यूम चेंज होगा, तो उसी चेंज को हम मेजर करते हैं कंप्रेसिबिलिटी से. कैसे भूल जाता है? जनरली के हम यूज करते हैं, के यूज कर लेते हैं. चलो के, दिस इज केस बल्क मॉडुलस ऑफ इलास्टिसिटी. अब कोई भूल मत जाना यार. इलास्टिसिटी एंड दैट इज v into dp upon dv minus, or you can say dp minus delta p into minus delta v upon v. के क्लियर है? Yes, it is inverse of compressibility. Clear है? Yes or no? Inverse of bulk modulus of is compressibility. And that is alpha is 1 by k, and that is what 1 upon v minus dv upon dp. क्लियर है? बोलो. तो माइनस dv upon v is what fractional change in volume with change in pressure dp. Any problem to anyone? कुछ भी याद करना है? Is there anything to remember? Please tell me. And the same thing you can write in terms of density. Here delta p into delta rho upon rho. Why positive? Anyone? And here also d rho upon rho in upon dp. In terms of density we can write here like that. Because as the volume will decrease, the density will increase with applied change in pressure. And that term is frequently used in thermodynamics, and that is frequently used in the fluid mechanics. Although the significance is same here, but the bulk modulus is frequently used in thermodynamics, in fluid mechanics, and alpha is going to use in thermodynamics. Now listen here. Alpha. What is the physical significance of alpha? Alpha is a measure of change in volume or change in density with change in pressure, fractional change in volume. Now, as I told you, if you recall, for liquids, for the liquid, the variation in density with pressure and temperature is negligible, am I right? Or you can say a very large pressure is required for a small change in density. Yes or no? If you want to have some change in density or volume of the liquids, then you should apply large pressure change. Large pressure difference will be required. A very large pressure difference will require for a smaller change in density. And then I told you, if you go for definition of density, I told you कि variation in density of the liquids with pressure and temperature is very small or negligible. जो डेंसिटी का वेरिएशन है विथ प्रेशर एंड टेम्परेचर बहुत ही स्मॉल है लिक्विड्स के लिए. तो अल्फा इज वेरी स्मॉल. यस नो? अल्फा इज वेरी स्मॉल फॉर द लिक्विड्स and alpha is very high for the gases. Yes or no? Because gases are highly compressible. So this is the reason why, because alpha is very small, and since inverse of alpha is called as k, then the bulk modulus of elasticity is very large for the liquids and very small for the gases. And while alpha is very small for the liquids and very large for gases, inverse is there. ये ध्यान रखना. तो alpha is very large for the gases and very small for liquids, while k is very large for the liquids and very small for gases. Because inverse is there. So large alpha means large value alpha. What does indicates you? Large alpha indicates you higher the value of compressibility, indicates you कि there is large change in density. Two ways we can define the alpha. Listen here carefully. सुन लो बस ध्यान खोल के. Higher value of alpha or large value of alpha indicates कि large change in density with a small change in the pressure. अल्फा अगर ज़्यादा है गैसेस के लिए, इसका मतलब क्या है? ओनली स्मॉल चेंज इन द प्रेशर विल कॉज फॉर लार्ज वेरिएशन इन द डेंसिटी और वॉल्यूम. इन वाइस वर्सा, इन अदर वर्ड्स यू कैन आल्सो से कि लार्ज वैल्यू ऑफ अल्फा आल्सो इंडिकेट्स यू वन वे इज कि लार्ज अल्फा इंडिकेट्स यू, हाई अल्फा इंडिकेट्स यू कि लार्ज वेरिएशन इन डेंसिटी विद स्मॉल चेंज इन द प्रेशर. अदरवाइज यू कैन आल्सो डिफाइन कि हाई अल्फा इंडिकेट्स यू for a small change in density, large change in the pressure is required. Are you getting it? Sorry. High alpha indicate you, we can define alpha in two ways. First of all, high alpha indicate you कि large change in density or volume with a small change in the pressure. Or for a given pressure, there is a large change in density or volume for high alpha. For a given pressure, there is a large change in density. In other words, for given change in density, only small change in the pressure is required. It is also correct, yes or no? Yes, for a given change in density, a small change in the pressure is required. A small variation in the pressure will cause given change in density. The two ways is there. One is for given only small change in pressure is required for fluid having high alpha. Yes or no? Or for given applied change in pressure will cause large change in density or volume for fluid having high alpha. Is this clear? Bolo. K is very high and alpha is very high. For what? Alpha is very high for gases and very low for liquids. K is very high for liquids and very low for gases. Clear है? Inverse is there. Alpha is 0 for liquids, na? And that's why it is called as liquids is called incompressible, because change in volume or density is with change in pressure is negligible. I've told you density variation of the liquid with the pressure is negligible. So it is close to 0, very very small, 0.001, 0.01, it should be negligible. The alpha is 0 and K is infinite for what? Liquids which are incompressible. Clear hai? Bolo. Two types of compression is there. We can compress the gas two way. One is thermally and adiabatically. Fluids can be compressed. Fluid can be compressed. Compress ही तो करना है. In following two way. In following two ways. One is isothermal, other is adiabatic. Isothermal and adiabatic means T is constant and here Q is 0. Actually reversible adiabatic, isentropic also called as reversible adiabatic, it should be also called isentropic. Two type compression is there, thermal and isentropic. Isentropic means reversible adiabatic. इसमें फिगर क्या है, तब से क्या लिख रहे हो भाई? इस isothermal and reversible adiabatic, and reversible adiabatic as a whole is called isentropic. Two types of compression is there. When isothermal is there, then T is constant. It means Pb equal to constant. Yes or no? When adiabatic is there, Pb per gamma is constant. Gamma is the specific heat ratio, Cp by Cv. भाई किसी गैस को कंप्रेस दो तरीके से कर सकते हो. एक तो रिवर्सिबल एडियाबैटिक मीन्स इस पिस्टन को कर दो इंसुलेट, and no heat can be lost. And why reversible? Reversible means no frictional loss is there also. So reversible adiabatic is isentropic. So when the PV per gamma is constant, and PV is constant for thermal and PV per gamma is constant for the thermal. It is clear below. Now my dear student, then for ideal gases, because liquids तो incompressible है, उसमें कोई दिक्कत नहीं है, हम gases की बात कर रहे हैं ना. Then for gases, PV equal to nRT. Temperature is constant, PV equal to constant. Then as alpha is what? What is alpha? 1 upon V into del V upon del P at constant temperature. Please differentiate this V from this equation, del V upon del P. Please solve and tell me the answer. It is constant. It means P into dV minus V into dP. It means dV upon V minus sign. dP upon P. पहले से लिखो फिर बताता हूँ. तो I can write here वो गर्ग साहब, dV minus dV upon V is dP upon P. 1 upon P. Alpha is inverse of the pressure. Means unit of alpha is what? Pressure inverse. Either atmospheric inverse or kilopascal inverse. It is for ideal gases, 1 by P. Yeah, for reversible adiabatic, always PV per gamma is constant. This I will discuss in the thermodynamics. For reversible adiabatic, always PV raised per gamma is constant. This will make the Q equal to 0. This PV raised per gamma equal constant, that will make the Q equal to 0. Mr. Sankar. So alpha is 1 by P for the case of ideal gases, and bulk modulus is what? Bulk modulus is K is equal to P for ideal gases. Yes or no? Bulk modulus is P, pressure. Sankar, clear? Now please solve for the adiabatic process. For adiabatic or for isentropic, Pb की power gamma is constant. It means P into V की power gamma into dP plus P into gamma into V की power gamma minus 1 into dV is equal to 0. Then V की power gamma into dP minus P into gamma V की power gamma minus 1 into dV. Okay, then please solve for dP upon dV upon dP alpha. dV upon dP is found to be dP upon dP V की power gamma minus P gamma into V की power minus gamma plus 1 minus V की power V upon P gamma. Yeah, and if you put here alpha is equal to minus dV upon V and dP adiabatic, it is 1 upon P gamma. It means K is equal to P into gamma. It means K for adiabatic process or isentropic process is gamma times K for isothermal. Am I right? And that you should understand. So this is what is the physical significance. Although I did formula, but physical significance is it is variation of the volume or density with applied change in the pressure. It is called as compressibility. and inverse of compressibility is called bulk modulus of elasticity. And for the liquids, the value of K is infinite and the alpha is 0. Okay, so I think there should be no any problem. Unit of alpha is pressure inverse and unit of bulk modulus is pressure itself. Now the next property is surface tension. Very important. Surface tension. The two important property has been left only, surface tension and viscosity, and one is vapor pressure. बोलो क्लियर है? यस, एनी प्रॉब्लम? मिस्टर उमर, किसी को कोई प्रॉब्लम हो तो भाई बोल दो अभी. हाँ, सार्थक. रिवर्सिबल एडियाबैटिक इज कॉल्ड एसिंट्रोपिक. रिवर्सिबल एडियाबैटिक मीन्स एडियाबैटिक मतलब क्या? नो क्यू इज इक्वल टू 0. यू हैव इंसुलेट द होल सिस्टम. सब कुछ यही सीख रहे हो क्या तुम लोग यार? गामा क्या है? Cp upon Cv is called gamma. Gamma are the specific heat ratio, sir. Cp by Cv. A specific heat capacity at a constant pressure to the specific heat capacity at a constant volume. Reversal means if you are going to compress the gas adiabatically such that no heat is going to be released due to friction, means viscous heat dissipation is negligible. It means frictional effect is negligible. That process becomes reversible. So reversible adiabatic as a whole is called as asyntrophic. That I will discuss in thermodynamics. Okay, and whenever the reversible adiabatic is there, always Pv per gamma is constant. Along with the isothermal path, Pv is equal to constant. समझ गए? Now surface tension. What is surface tension? Anyone? As the name suggests, tension in the surface. Tension means what? Force per unit length. A force in the surface is called as surface tension. So due to surface tension, what happens? The surface molecules of the liquids. Actually, first of all, you should know it is combined property. The surface tension is not the single property; it is combined property of the fluid. And when the liquid is in contact with the gases, or the two liquids of different densities are in the contact, then in the liquid surface there is always some force is going to act, and that force is called a surface tension force. ध्यान दो मैं क्या बोलना चाह रहा हूँ. पहले आप बताओ, what is surface tension? Mr. Umar. Surface tension means when the liquid surface is in the contact with the gas, or two liquids of different densities are in contact, then there is always some force is going to act in the liquid, is called a surface tension force. Yeah, surface tension, you can say a tensile force acting on the surface is called a surface tension force. Yeah, due to surface tension, the surface, yes, very good Moria. The surface tension, due to surface tension only, the fluid has a tendency to reduce its surface area. It will try to minimize its surface area of the given volume of the fluid. In given volume, the minimum surface area is going to be only of the sphere. That's why whenever any drops are going to be fall from the faucet, it acquire the small drops. I'm talking. Why not large drop? Because large drop have gravitational force will dominate. Then it will become elliptical. Or you can say even the large drop, if falls under the zero gravity, then it will be perfectly spherical. But we can also observe small drops, because in small drops the gravitational force is small. Due to when the small drops are fall from the detached from the faucet, it will acquire the spherical shape. Why? Because in the given volume it will try to acquire the minimum surface area due to surface tension only. I am going to just tell you applications. A spherical shape. Okay, in a given volume the minimum surface area is only by the spherical shape. That's why these all are the applications of surface tension force. And due to surface tension force only, you can place the needle, we can place the hairpin on the liquid surface if you are going to place gently. If you are going to place the needle or hairpin or paper pin on the liquid surface gently, then it can float. It is only because of surface tension. Because the surface means surface molecules of the liquid. The surface molecules of the liquids are in tension, and we can assume that surface molecules of the liquids, any liquids molecules on the surface or surface molecules, and they are acting as a thin stretched membrane. We can assume that it would have been acting as a thin stretched membrane. Yes, bugs floats on the water strider, because water strider have a well, their legs are well designed so that they can whole weight can equally distributed. The water strider can happily move over the liquid surface. है कि नहीं, है देखा भाई, कीड़े, पानी के जो कीड़े होते हैं वाटर स्ट्राइडर, वो पानी के ऊपर तैरते हैं. Why it is only because of surface tension? Because due to surface tension, I've told you, whenever the liquid surface is in contact with the gas or air, or when the two liquids of different densities are in contact, and at the interface, the liquid surface is always in the tension. As at the interface in the liquid, the force is going to act, and due to this force, what happens? The surface molecules of the liquid is in the tension, and due to this tension, the surface is assumed to be acting as a thin stretched rubber sheet. Actually, it is not acting as a rubber sheet, but it is assumed it would have been acting as a thin stretched rubber sheet. Yes, पानी के मच्छर देखा होगा आपने, मच्छर पानी पे बैठ जाते हैं आराम से. मच्छर जो होते हैं mosquitoes, they can sit on the water itself, water surface. Why you are going to place the kerosene in the nalas? Because if you are going to place the kerosene, it will reduce the surface tension. So as the surface tension decreases, then it will simply dip down. They are not able to walk happily, they will walk sadly, they will sink down. So these are all example of surface tension. So due to surface tension only, the surface molecules will try to acquire the minimum surface area. तो डेफिनेशन मैं बाद में बताऊंगा. डेफिनेशन क्या बोलता है? सरफेस टेंशन का टेंसाइल फोर्स एक्टिंग ऑन द सरफेस पर यूनिट लेंथ इज कॉल्ड एज सरफेस टेंशन. दैट इज डिफरेंट थिंग. वो क्या है? टेंसाइल फोर्स. ठीक है, बट जो अभी मैं बात करूंगा, फॉर एग्जाम्पल लिसन, नाउ व्हाट द डिटर्जेंट डू? Detergent or soap, they actually reduce the surface tension, and as the surface tension will get decreases, then what happen? The water can easily enter into the pores of the cloths, and there is more probability of cleaning the cloths when we are going to use the detergent or surfactants, because it reduces the surface tension. Otherwise, if surface tension is there, पानी से भी कपड़ा साफ होगा, बट द वाटर मॉलिक्यूल्स इज नॉट एबल टू पेनिट्रेट विद इन द थ्रेड्स ऑफ द क्लॉथ्स. आर गेटिंग इट? जो मैक्सिमम होगा, दे विल एबल टू, बिकॉज ऑल द गंदगी, क्या बोलते हैं उसको, मड्स, और इन द थ्रेड्स, इन बिटवीन द थ्रेड्स ना ऑफ द क्लॉथ्स. देन इफ यू वांट टू remove it, then obviously water has to be passes through it. But if you are going to use the surfactants or detergent, it reduces the surface tension, and so that water can be wet. Water can wet the cloths, and water can passes through the pores, and there is more chance of cleaning dirt. Wow. लोग बोलते हैं गर्म पानी से कपड़े धुल दो, साफ हो जाएगा. क्यों? It means by increasing temperature, the surface tension can be reduced. Yes or no? If temperature increases, गर्म पानी में कपड़े जल्दी साफ होते हैं अच्छे से. क्यों? बिकॉज एज टेम्परेचर इंक्रीजेस, सरफेस टेंशन विल गेट डिक्रीजेस. Mr. Karthik, we are using the hot water to clean the dirty cloths, because by increasing temperature we can reduce the surface tension. Okay, now, but actually what the surface tension is, I told you everything. Because due to surface tension, the surface molecules have tendency to acquire the minimum surface area. But why minimum surface area? Why they have only surface molecules? If suppose, listen here, if you have a bucket and this is filled with the liquid, no? So this is the surface of the liquid. This I am talking about this surface. How many of you got my point? I am talking about any liquid molecules which are on the surface. This surface. Surface means when any liquid is in the contact with the gaseous is called a surface. Surface has interface. Liquid surface has interface of gas. So mosquitoes are standing on the water surface only because of surface tension. Answer बहुत easy है, due to surface tension. How the water striders, पानी वाले कीड़े क्यों पानी में चल लेते हैं? Due to surface tension. Because due to surface tension, ना अब हाथी को नहीं तुम तैरा सकते हो. पेपर पिन को कभी देखा आपने? पानी के सरफेस पे कभी पेपर पिन रख दो. पेपर पिन ऐसा होता है ना, इस टाइप में पेपर पिन. You can place the paper pin on the water and it will never sink down. But you should place gently. Gently means just you can do your experiment on the glass of water. Just use a tissue paper and place the paper pin, and place as a whole with the place the paper pin along with the tissue paper, and with the pen pinch the tissue paper and you will find this pin will remain on the surface. Why? Because I told you, because weight of the pin is small. And listen, why the small object can be float? Because the magnitude of surface tension force is very small. उतना ही फोर्स वो विथ एक्सटेंड कर सकता है जितना फोर्स उसके पास है. तो सरफेस टेंशन इज वेरी स्मॉल इन द मैग्नीट्यूड. सरफेस टेंशन फोर्स इज वेरी स्मॉल इन द मैग्नीट्यूड. हाँ, निडल भी तैर सकता है बट जेंटली प्रेस करो. ऐसा नहीं कि मतलब पहले हाथ घुसा दिया, निडल पहले बाद में जा रहा है. ऐसे घुसा है तो हाथ पहले टच कर गया, हाथ टच कर जाएगा फिर क्या होगा? अच्छा, कभी टच किया होगा आपने, एक वाटर है, वाटर पे अगर तुम जस्ट फर्स्ट फिंगर टच करो और फिर उठा लो जल्दी से, फिर क्या होगा? यू विल सी कि इट विल जस्ट एक्टिंग एज अ मेम्ब्रेन. पिन बाद में गया, उंगली पहले घुस गई. हाँ, हो सकता है कि टाइम की इशू हो, क्योंकि टाइम 8:30 तक ही था, इसलिए इशू हो सकता है. तो विल कंटिन्यू बाय टुमारो, है ना? तो समझ में आया या नहीं आया कुछ भी बोलो. ओके, बहुत ईजी सब्जेक्ट है, बहुत ही इंटरेस्टिंग है. तो थैंक यू सो मच. विल कंटिन्यू टुमारो द 2 important properties, surface tension and viscosity.